Our next topic is risks associated with control charts. Let me ask you a question. Can we always trust the control charts? The answer is not always, but most of the time. What do we mean by most of the time? 99.7% of the time, the control charts draw correct conclusions, but 0.3% of the time, they lead to incorrect conclusions. Let me summarize this using a table. On the side, we have the true state of the process. The true state of the process can be either in control or out of control. Everything is working properly or there is something wrong in the process. The true state of the process is hidden to us. We can only sample some of the observations, use these observations to construct the control chart, and use the control chart to make a conclusion. And our decision is based on the samples only. And our decision can be either in control or out of control. Let's look at each of these scenarios. First, the true state of the process was in control, but based on the control chart, we conclude the process is out of control. Are we making the right conclusion? No, we are making a wrong conclusion. This is a type 1 error that happens 0.3% of the time. Remember, 0.3% of the time, the sample mean falls outside the control limits even if the process is in control. So that's when we make a type 1 error. Next, the process is out of control, and we conclude that the process is out of control. Are we making the right conclusion? Yes. Next, the process is out of control, and we make a decision and say it's in control. Are we making the right conclusion? No, this is type 2 error. And next, the process is in control, and we conclude that the process is in control. Are we making the right conclusion? Yes. So we looked at all possible scenarios, and I want to focus on the type 1 error, and I want to illustrate this using a tape example. Think of a production line producing Coca-Cola products. The target filling weight is 15 ounces. And these are the actual products produced. The first bottle was 14.8 ounces, the second bottle, 15.2 ounces, and so on. And some of the bottles are overfilled and some of the bottles are underfilled. And let's assume that the process is in control and the average of these is 15 ounces. And we are making the control charts and we don't observe all of them. We only sample a few of them and use them to make a control chart. Now, when we sample these bottles, we may sample some of the underfilled bottles accidentally. And if that happens, the sample mean could be lower than the lower limit. And based on that, we have to conclude that the process is out of control. And that's the case when we make a wrong conclusion because we base our decision on a sample, not the entire population. We can sample these underfilled bottles accidentally.